Welcome back. In this session, we are going to discuss the architecture of Dedicated SQL Pool, its use cases, and the pricing model. Dedicated SQL Pool is basically a distributed analytics engine that you can use to perform high-performance big data analytics using the familiar SQL language. Unlike the serverless SQL Pool, Dedicated SQL Pool also offers a data storage solution that stores data in a tabular structure with column in a format. So it's basically a traditional data warehouse with a massively parallel processing engine. Some of you might already be familiar with its old name Azure SQL Data Warehouse before it was incorporated into Synapse as Dedicated SQL Pool. Let us now take a look at the architecture of the Dedicated SQL Pool. It uses the driver node, worker node architecture you generally see in distributed computing, just that the driver here is called the control node and the worker is called the compute node. Applications or users connect to the controller, which runs the distributed query engine. Once the control node receives the query, it optimizes the query and then passes the instructions to the compute node to do their work in parallel. Once the compute nodes complete the tasks, the results are then returned to the control node. It then returns the result back to the application or user. The key difference between serverless SQL Pool and the Dedicated SQL Pool is that the Dedicated SQL Pool comes with an internal storage. The storage is split into 60 distributions to enable parallel processing. Each computing part is assigned equal number of distributions. So, for example, if the Dedicated SQL Pool has only one compute node, that would be assigned all the 60 distributions. On the other hand, if the Dedicated SQL Pool has 3 compute nodes, each of the compute nodes will be assigned 20 distributions. So when a query is executed by a compute node, it only processes the data from the assigned distributions. We can have up to 60 compute nodes for maximum parallelism so that each compute is processing data from only one distribution in some circumstances, such as joins or aggregations. We may require data from multiple distributions to be joined in order to perform the task as requested by the query. This is facilitated by the system-level internal service called Data Movement Service, or DMS. The Data Movement Service, or DMS, runs on every node in the pool. In this architecture, storage and compute is decoupled so you can scale up and down your compute without affecting the storage size or moving the data. We can even pause the compute when it's not required and resume during the operation hours. This helps save cost of the service, which is significantly higher than the other services and Synapse Dedicated SQL Pool uses as a storage to keep the data safe. So there is a separate charge for the storage of your data. As it's utilizing the storage, we get all the benefits that come with that. For example, you get durability, geo-redundancy, etc. As we discussed before, the data in the storage will be sharded into 60 distributions to parallelize the work and optimize the performance. We can choose the sharding pattern used to distribute the data for each of the tables separately. The sharding patterns available are round-robin hash distribution and replicate. Round-robin randomly distributes rows evenly across the nodes. It's not optimized for performance in joins and aggregations as there is no logic on how the data is split. It's mainly recommended one layer for staging tables. In hash distribution, rows are distributed across nodes using the hash value of the distribution column. The SQL uses this column to distribute the data across distributions, storing all rows with the same value in the same distribution. This type of distribution provides the maximum query performance for giants and aggregations on large tables, so it's recommended for fact tables and larger dimension tables. Replicate the distribution keeps a copy of the entire table in every distribution as it's making 60 copies of the data. It's really slow to load, but the query times during joins are extremely fast as there is never be a need for shuffling of data between the nodes. It's only recommended for smaller dimension tables as keeping 60 copies of the data is not cost-effective and also it doesn't help at parallelism. Let's now go through the use cases for the dedicated pool. This is a great data warehousing solution for modeling your data with facts and dimensions and building star schemas. Typical support in Dedicated SQL Pool enables us to create slowly changing dimensions and facts without using any workarounds, unlike in data lake-based solutions. Since the tables in Dedicated Physical Pool are always spread across 60 distributions, performance gains are not typically realized until your data warehouse is more than 1 terabyte. As a general rule, data warehouses of less than 1 terabyte will perform better on Azure SQL Database than on Dedicated SQL Pool. From my personal experience, I would encourage you to use Dedicated SQL Pool only your data warehouse is going to grow to larger than around 4 terabytes to realize cost benefit. As the data is stored in the internal storage with indexes, partitions, compression, etc. We get instant responses from the queries as opposed to reading data directly from the files in the data lake, so it's a great service if you need instant response times for your queries. Unlike serverless solutions, we can build solutions using Dedicated SQL Pool with predictable performance as we provision the resources required. Also, we can scale up or down the compute to adjust the performance required. So it is a suitable solution when you have strict service level agreements on your predictable performance. The resources we provision for the Dedicated SQL Pool is measured by Data Warehouse Units DWUs. I just think the DWUs will increase or decrease the amount of compute nodes provisioned and the relative performance of the service they build based on the database units. Each database unit relates to an amount of CPU memory and I/O. The table here shows the relationship between data values units and the compute we get from them. Each compute node comes with 300 gigabytes of memory. If you choose DW500C, you will get one compute node with 300 gigabytes of memory. DW1000C will give you 2 compute nodes with a total of 600 gigabytes of memory. From here, increase in every 500 data units gets you an additional compute node all the way up to 60 compute nodes for DW30000C. The first 4 performance levels DW100C to 400C. One only gives you a portion of the compute nodes. They're good for development workloads, but they're not recommended for production workloads as you will be on a shared tenant, which may not give you predictable performance. The middle column here tells you how many distributions are allocated to each compute node. As you can see, when you have one node, all 6 distributions will be processed by that node, and then you have 60 nodes. Each node is processing that data from just one distribution, and you get maximum parallelism. So that's the end of this session. Hope you have a good overview about Dedicated SQL Pool, its architecture, and its use cases. I'll see you in the next session.